Hello guys, welcome back to my channel Code Organization. Today we are going to solve the question task scheduler. So in this question, we have given a character array task representing the task a CPU needs to do, where each letter represents a different task. Task could be done in any order. Each task is done in 1 unit of time. Each time of unit, the CPU could complete either one task or just idle. Okay, however, there is a non-negative number n that represents the cooldown period between two same tasks. Okay, that is, there must be at least an unit of time between the same two tasks. Okay, return the least number of unit of time that the CPU will take take to finish all the given time. Okay, so if we can look at this question, we can how can we think of this type of question? Because here two, if I am doing a task, so I can't do a task for 2 unit of time. Okay, if I have to do, I will do after 2 unit of time. So in order to minimize, because this is task scheduler and we have to minimize the number of the least number of unit of time. So what can we do? So uh, we want to minimize the number of tasks by which we can just perform the task. Okay, so we will try to minimize how much work we are doing. So that's why we don't want our system to be idle, because if it is in the idle state, then it will be very much tedious for our CPU, because it will waste our time. So that's why what we are going to do is we are going to use a greedy method or the priority queue. So in the priority queue, what we are going to store, we are actually going to store how, because a has a frequency of 3, b has a frequency of 3 also, and n is equal to 2. What this means is actually that if I take a task, then I can't because it has to be idle, so I will take b. Okay, after this I have to take a idle step, because these are the two idle states, because one is where b is performing its task, and the another task is where idle state is going on. So that's why I'm just going to place my IA here. So how we are actually going to solve this question, because this is a really tricky question. So in order to think how we are going to solve this question, so what we are going to take, we are just going to take an unordered map. In unordered map, what we are going to store, we are actually going to store A frequency and B frequency. So here A frequency is 3 and B frequency is also 3. So what I am going to do, I am going to put frequency only, because we only need frequency. So right now A frequency is 3. So what I am going to do, I am just going to push it into my priority queue. Okay, after I push it into the priority queue, what I am going to do, because now I am considering a task. So right now my a task is actually performing. So while my a task is performing, what I am going to do, I am just going to decrement its value, which is now 2, and I will store it into a temporary vector. Okay, after this my b is actually 3. So and it is also at the top. So what I'm going to do, I'm just going to decrease its value, and I will push it into the temporary vector. Now b is actually working, but now I can see that my size of, for the ideal size, is actually 2. Okay, and here the size is actually 0 and 1. So it is not, it is like n plus 1. Okay, so it has to wait for one cycle in order to perform a from here. So that's why it will just wait for one cycle. After it will wait for one cycle, it will just resume its task. Okay, so that's how we are actually going to solve this question. This is actually the algorithm. So now let's move to the coding part. In the coding part, as I told you, we will make an ordered map. Unordered map, why? Because we are just going to store the frequency, because we need frequency only. So that's why we are just taking care of frequency. After we store the frequency, we are just going to push all these frequency into our priority queue. Now the priority queue is the priority, why we are actually storing this into the priority queue, because priority queue is based on the max heap concept, and max heap concepts are in which the if we pop out the first element, it will be the maximum among all these frequencies that we have just stored. So after I stored everything, what I am going to do, I am just going to create a variable which is result, and after all the iteration I will return the result. Then what I'm going to do, if this is a which corresponds to 3 and b which corresponds to 3 also, so what I'm going to do, I'm just going to create a temporary vector. In this temporary vector, like if this is 3, okay, if this is 3, what I'm going to do, I'm just going to, because this is 2 now, now this is 2, and then I will just pop it, and my time is actually going to increase. Okay, my time is actually going to increase, and I will run it till I to n plus 1. Why n plus 1? Because my ideal state is my n is actually telling me how many ideal states I need. So if I perform A right now, so after 2 ideal states I can perform A repeatedly, okay, or the next time after 2 states. That's why this is n plus 1. So after I perform A, now I need another thing that I can perform. So after I perform A, its values become 2, and B is actually there. So I will perform B, and its value become 2. Here it is 2 also. So it will become 2, and I will store it into my vector. After this, I can't use both of them, because if I use them, it will just break the condition. Okay, so that's why I will just wait for an ideal state. After I wait for ideal state, I'm just going to increase my time, and then I'm just going to iterate. I'm just going to iterate to this vector. Okay, this vector is actually will tell me if this is if I have actually value or not. If I don't have any value, this means that my priority queue is empty and I am not able to perform much more steps. But if it is not empty, then I am just going to push all these elements again into the priority queue, so that in the next iteration everything will be solved correctly. Okay, after this, what I'm going to do, I'm just going to make it the result, which is the result with, if my priority queue is empty, this means, like if I told you like this, if I have elements like A, B and C, right, and my n value is actually 6. Okay, now for the first step, when I have n is equals to 6, or let's take an example, if n is equals to 3, right, so I can use A, B and C, but let's assume that my B and C are just cancelled. So I don't have to wait for these steps, like I don't have to wait for 1 to n index, right, I don't have to wait for this, I just have to wait for the time, on how much time this element is consuming. So if this is empty, I am just going to use my time, but if it is not empty, this means that I am using every time options, and if I am using every time option, this means that I am just iterating for n plus 1 time. So that's why this is n plus 1. So this is the whole this is whole the algorithm as well as the coding part. I hope you like the video. Make sure to like, share and subscribe for more upcoming videos, and thank you for watching.